This is number 14 on lesson 87, and I've got cosines and sines in my problem, and I would like them to all be sines, so I'm going to replace cosine squared x with something that one of you guys needs to tell me what I'm going to replace it with. Who knows what I can replace cosine squared x with? One of my identities.
1 minus x squared.
Yes, sir. Why is that? Because we know that sine squared x plus cosine squared x equals 1. So if you just, tweak that around a little bit, you'll have 1 minus sine squared x. Okay, so then we're going to just do the problem. Did I do this problem yesterday or just another one that was kind of like it? Okay. Yeah. Oh, we played the game. I love playing the game. Okay, so now I have negative 2 sine squared x plus sine x, and then the 2 and the 1, I guess it's going to give me 3. And I don't like negatives in front of my lead coefficient, so I'm just going to multiply through by negative 1, so it doesn't have to be that way. And then I'm hopefully going to be able to factor this, and if not, I will have to resort to the quadratic formula. 2 times negative 3. You're using the quadratic already? Ah, 3 times 2 would have worked, though. Negative 3 and positive 2. But you're kind of right in a way, Cameron, because when you have that coefficient right there, you have to do all these extra steps. Like, you had to multiply this lead coefficient with this constant, to figure out that number, and then you also have to do this area model box. You can't just say, oh, it's x minus 3 and x plus 2. You have to use the area model. So you might just be faster using quadratic. What goes in the two sides right here? Anybody know? See, I got for this first upper left box, I used the first term, and I used the lower right box as the third term. And the negative 1, remember we split it into, it's the same as negative 3 and positive 2? These go in the two side boxes. It doesn't matter which way you do them. And then you figure out what goes up above, like this is going to have a sine x. Sine x times sine x equals sine squared x. But there's a 2, so I have to decide if I need to put the 2 on the top or on the side. On the top. He says put it on the top. Because, see, if I put it on the top, it goes into both of these. So, because we know this times this has to equal this, and it does. This times this has to equal this, so this has got to be 1. And this times this, so that's got to be what? And then this times this equals that, so that's all good. So now I know what my factored form is. It's sine x plus 1, and it's 2 sine x minus 3. And then zero product property says set each one of them equal to 0. Well, that's going to give me sine x equals negative 1. And inverse assign it, and I'm going to have x equals whatever sine x is negative 1 on the unit circle right there, I think, isn't it? Yeah, it's going to be 270 degrees. Yeah, are we in degrees in this problem? Yes. Okay, now this one right here is going to give me 3 over 2. It's going to give me sine x is 3/2. Can sine x ever be 3/2? I know, it's this weird thing that says, well, it's not weird. If you think of the graph of sine, it goes, the parent function, oh, that doesn't even look like, that was cosine. The graph of the sine function, it goes in between 1 and negative 1. So 3/2 is 1.5. That would mean it's not in the domain of, this one, basically, you have to throw in the trash can. So what, did you get another one though, Seth, or is that just the one you got?
I asked for this, so.
Oh, okay. I was gonna ask you if I got it right. I'll ask the,
I'm not sure about
yeah, I'll ask the answer book if it's right. Yeah, there's only just the one answer, just this is it. 'Cause we had to throw the other one away, 'cause it was outside of the range. So basically, if it's, the absolute value of it is greater than 1, then it's no bueno.